y1 minus y formula.
Y minus y1, yes. Very good. Good. So what is this? Good. What is this? Very good. What is this?
When you plug in 0 into the original function.
Very good. Excellent. So y minus 7 equals negative 2x, because that's 0, and I add 7. Great job. Good, so let's look at some functions to differentiate and some limits. L'Hopital's rule I would like to review. L'Hopital's rule is at the end of chapter 2. I'm sorry, chapter 1, of course. On page... where is it? Page 175. At the very top, right? And other limits. 84. 84. I was just looking at a different page already. 84. Good. So the limit x approaches, I think it's negative infinity, yes. From 3x to the third plus x plus 11 over 6x cubed plus x plus 2. Perfect. So when you plug in infinity, so to speak, in the numerator, what do you get? And which terms count?
Just the ones with the
Okay.
highest degree.
So the highest degree counts when we talk about infinities. So where does the numerator go then? Good. Infinity or negative infinity, that's fine. What about the denominator? Where does the denominator go? Same thing, there is no difference, right? If it's 6x cubed or 3x cubed, there is no difference. They go to infinity or negative infinity, right? Good. So this is a typical situation for L'Hopital's rule. There are only two, 0 over 0 or infinity over infinity. And only in this case, we can differentiate. We differentiate the top and we get 9x squared plus 1. Differentiate the denominator, we get 18x squared plus 1. We plug it in. Where does the top go again? Very good, both of them. So I continue with the same rule. Limit as x approaches negative infinity, the top is 18x, the bottom is 36x. Simplify the x's now. I could not do it here. So please do not simplify one x from the top with an x from the bottom. They are not factors. But here they are factors. And now I simplify 18 with 36, and the answer is 1/2. And then this is y equals 1/2 is a horizontal asymptote. Good pick. Okay, let's look at some derivatives and other limits. More limits on page 182. And some derivatives with quotient rule, product rule. They are on page
49 on page 182.
182, number? One more time.
49.
49. Where are you? 49. Oh, yes. Perfect. Excellent. So 49 on 182. Perfect pick. 49. So g of x equals 5 minus x squared. And then 2x minus 1 to the fifth. Awesome. Perfect. So this is function 1, this is function 2. So g prime will be function 1 prime. 2, 5 minus x to 2 minus 1 times the inner function prime, negative 1, times the second function, 2x minus 1 to the fifth, plus, I continue here, first function, untouched, times the second function, 5 in front, subtract 1 from the power, times the inner function prime, 2. We cannot leave it like this. We have to fully factor. So, I see a 2. I see a 5 minus x in both. And I see 2x minus 1 and 2x minus 1 in both. So 2 is out. 5 minus x to the smallest power. Power 1, power 2. It has to be power 1. I shouldn't write it like this. I'm just making a point. And 2x minus 1 to the smallest power. So it's 4. Bracket now. Let's see what is out. So this is out. This is out. 4 from here are out. So there is 1 left. And there is a minus 1. So minus parentheses 2x minus 1. So this is completely out. This is completely out. 5 of those, 4 of those 5 are out. So there is 1 left in and with a minus. Now I reach this point with plus. 2 is out. 2x minus 1 to the fourth is out. Out, out. 5 is not out. I don't have it. So it's 5. And from 5 minus x squared, I took 1 out. So then parentheses, 5 minus x. Close. I need to calculate this. So this is negative, simplify it. Plus 1 plus 25 and minus 5x, combining like terms. Negative 7x plus 26. And I will factor out negative 1. So the final answer is negative 2, parentheses, 5 minus x. 2x minus 1 to the fourth, and here the 7x minus 26. If you want everything to be nice and neat, you will factor out here negative 1 and write x minus 5, and that will change this sign. So if you want, it's 2x minus 5, 2x minus 1 to the fourth, 7x minus 26, and this is it. Any questions on this? Good pick. Anything else that you would like to look at? Anything else? Let's look at more derivatives. So this was let's look also at the quotient if you'd like, or a chain rule. This was a chain rule included. What if I have something like, give me any function? We already used it here, but let's do one more. Give me any function. Any function? Anyone?
X squared plus 6.
Good. Okay, so how do I differentiate this? We already used the power rule and the chain rule. Bring down 10, 4x squared plus 6 to the 9th power times 8x. And I will just rearrange it, right? 80x, 4x squared plus 6 to the 9th. Anything else? Let's go back to limits. At the end of chapter 1. On page 289, let's maximize profit or minimize cost, like 43 or 44. You choose. Page 289.
43.
Very good, 43. Maximizing profit. So we're given the revenue, 52x minus 0.5 x squared, and C of x, cost, 22x minus 1. And find the maximum profit and the number of units that must be produced and sold in order to yield the maximum profit. Good. So first of all, I have to create a function. P of x is always the revenue minus the cost. And we know that. So I'm just going to carefully remember there is a minus in front. They has to be distributed to both terms. So 52x minus 0.5 x squared minus 22x and plus 1. Both signs have to be changed to the opposite sign. So then in the correct order, negative 0.5 x squared, 52 minus 22, so positive 30x, and then plus 1. So I have the profit function. I want to maximize it. I want to find its max, min, whatever I need to do. So how do I determine the maximum or the minimum? What will be the next step?
Derivative of the profit function.
Awesome. So this will be negative x plus 30. Excellent. I found the derivative. Now what do I do?
Find where it's equal to 0.
Very good. So then I have x equals 30. Excellent. What do I do now? I have to study the sign. I have to show why this gives a maximum. See, if I put in 0 in this function, I get a positive number. But if I put 100 in this function, I get a negative number. That's all I need. It's very clear. The function is increasing when its derivative is positive, and the function is decreasing when its derivative is negative. So this must be a maximum. Now the maximum value will be determined by P of 30. P of 30 will be the maximum profit. I have to plug it in. So when I plug it in, let's see what we get. So I have negative 0.5 multiplied by 900 That's 30 squared plus another 900 and plus 1. And I got 451. Maximum profit, 451. Perfect pick. Okay. From chapter 2, I cannot think of anything else. We may be asked to find like this one, increasing, decreasing intervals on a function, maybe the inflection point. So what would you like to continue with? We want to look at a function, find its